Problem 3. Longest substring without repeating characters. So to solve this problem, we need to know two concepts, sliding windows and sets. A sliding window is exactly what it sounds like. It's a window that slides over an array or a string. In our case, it's a string, but for the sake of example, let's consider this array. A sliding window, for example, will be something like this, an array of size 3 that slides across the entire array. Now, it's worth noting that sliding windows do not have to be static in length, meaning this array can be dynamic, and you can adjust the length of the window as you slide it along. And we'll see this in action for the problem. But for now, what about the second concept, which is a set? Well, a set is it's a data structure that contains one of each unique element. So consider a list 1, 1, 2, 2, 3. What would be the set of this list? Well, let's iterate through the list. First, we have 1. There's nothing in the set, so we put 1. But after we go to the second one, 1 already exists in the set. Therefore, we do not add it twice. So we skip it and move on. The same goes for 2, and then we go to 3, and there's no 3, so we put a 3 in the set. So basically, a set contains all the unique elements in a list or any other data structure. So with this, let's try to work out the example and see how these two concepts come together. So the criteria is we want to find the longest substring within the original string, and it doesn't have to be the most repetitive, like it's not the most occurring substring, it's the longest one with no repeated characters. That's why we need sets. So what we would do is that we will maintain a set that contains all the current letters used in our current substring, and we would iterate upon the substring by sliding where the substring begins and ends through the iteration of the string. So let's work it out. We have A, B, C, A, B, C, B, B. We will use 2 pointers to denote the start and end of the substring, and they would always begin at the same position. So it would start at the beginning with the left and right pointers at A. So at A, our set will contain A because we use that letter, and our current length, right, is going to be 1, and the result is currently 0. Every time we have a valid substring, we want to see if we can get a longer substring. And to do that, we move the right pointer. The right pointer will always move right to increase the length of the substring. So now the right pointer is here. AB is a valid substring because the set is not violated, right? There's only 2 letters. So the length now becomes 2. And 2 is a valid substring AB, so we can keep going. Right now gets updated to here at C, and likewise it works, so this becomes 3. And now we move the right pointer again to here. Now we realize that right is pointing at A. A exists within the set, therefore this is not a valid substring. Therefore what this means is that we can now update the result to 3 because we have found the longest current best substring. So this now becomes 0, gets reset, and we have to update the left pointer to start at a new starting point because we need to get rid of the redundancy, which is A. So we move the left pointer right by 1 position, which means it now points at B. BCA is a valid substring, and as we do that, we have to remove the corresponding letter in the set. So BCA, right, is still going to be a valid solution, and right is still pointing at A, so we have to update the A back into the set. And you see where this goes. We keep going with this pattern where if the substring is valid, then we move the right pointer by 1. And if the substring is not valid, then we move the left pointer by 1. This ensures that we never reconsider duplicate computations, and we always move forward, meaning we will always get a O of n solution to match the time constraint. So let's program this up in Python. So from our example, we know we initialize the left pointer to be 0, the right pointer to be 0, and we initialize a set. Let's call it used letters to be a set. And the result that we ultimately output for now has a length 0, and we can now start finding the longest substring. So while the left pointer is less than the length of the string and the right pointer is the same, we can iterate through the string. So what can we say? If the current character at the right pointer is not in the set, then that means that we are currently at a valid substring. So we would say we would add the current letter into our set and say if right minus L plus 1 is greater than the result, then the result has to be R minus L plus 1. And R minus L plus 1 gives us the length of the substring inclusive of the two endpoints. So what happens otherwise? Well, otherwise we would have to update the right pointer, right? Because now we can move on to the next character to consider. But what if, the right character is within the set? That means that we have a duplicate within the current substring, and we have to remove that duplicate. And we do that by moving the left pointer. We always move right. We never go back. So what can we say? We can say that we would use letters, right? Use letters is going to remove the current element at L. And we would do that and then update L to be L plus 1. And that's the algorithm. We're going to keep doing this until we find the proper substring, which we will return its length, which is stored in res. So let's run it. And it works, so let's submit. And it passes everything, and that's the solution.